everybody. Just in the last couple of clicks away from getting ready to record this video for you. So we're looking at Unit 2, which is Chapter 3, where we're studying the quadratic functions. And actually, I could correct that. It is Unit 2 includes Chapter 3 and Chapter 4, because both of those are covering the quadratic functions. In this lesson, we're going to take a look at Section 2 of Chapter 3, where we look at the quadratic function in standard form. So the purpose of this lesson is to make sure that you understand what we mean by the standard form, and then so that you are able to graph quadratic functions that are given to you in the standard form. Vocabulary is the same as it was for the vertex form because basically we're focusing on all the different parts of the function itself or the graph, the vertex, the axis of symmetry, whether there's maximum or minimum values, domain or range. And though it's not included in here, we will also talk a little bit about the y-intercept as well. So when we use the actual vertex form of the quadratic function, we are able to identify the vertex of our function very, very easily. It's just like taking fruit off of a tree, really, because it's staring at us. So when we look at something like this, we know that the vertex is the p value and the q value, and that is exactly, basically, the function has gone up q and it's gone to the right p, and that gives us the location of our vertex. But now the question is, what is the standard form of the quadratic function? We like to say it's when we put all our ducks in a row and we organize everything so that the things that have the highest exponent are first, the things that have just an x are next, and the things that have a number come at the last. So we call this descending order, and we usually use the coefficients a, b, and c to kind of give us an idea of this. This is what we call the standard form. So the question is, all right, if I'm given the standard form, can I still identify all the different parts of the quadratic function from the standard form? Okay, so first of all, if I give you the standard form of the equation, can you tell me what direction the parabola is opening? Well, the good news is the a that was in our vertex form is still here in the standard form, and it still gives it away. If this a is a positive number, then it opens up. If it's a negative number, it opens down. If it's a number like larger than a 1, then the graph gets skinnier, closer together. In other words, gets higher faster. And if it's a number that's smaller than 1, a fraction of some kind, it starts to spread out a little bit. So we say that the direction is given to us by the a value. How about the y-intercept? Turns out this one's very easy. The y-intercept is the place that the graph crosses and touches the y-axis. So the x value going this way is a 0. And if you put a 0 here and here, it shows you that your y-intercept is basically the c. It's the number that sits at the end of the standard form. X-intercepts, so places that it crosses the x-axis. Well, for these guys, we know that y is equal to 0. Now, we won't actually calculate x-intercepts at this stage yet. We're going to wait and do that actually in Chapter 4. But at least you understand that it's where the y is equal to 0, and that's where we begin with it. The vertex. Now, here's the one that takes a little bit more work because we need to figure out where this vertex is, and it's not obviously here. So what most of us use is a simple little formula where x is equal to negative b over 2a. We take whatever that coefficient is here and turn it into a negative, and we take the a and multiply it by 2, and that gives you the x value of your vertex. Once you know the x value, whatever number it is, you can plug it back into this equation to find the y value. So let's try some sample questions so you can see what's happening. So the first one is name the vertex, axis of symmetry, the maximum, minimum, the domain, and range for this function. And it's not right here. You'll see it in the next stage. So here it is. Here's your function. So first of all, your vertex, we're going to find that x is equal to negative b over 2a. So we take the b, which is 2, turn it into negative 2, and we say 2 times the a, which is negative 1. When we simplify this, we're finding that it is a 1. Once we know that x is a 1, then we can plug it back into our equation in the spots where we see x and calculate it. Turns out that it's 9. So my vertex is 1, 9. The axis of symmetry is that place which goes straight through the vertex, and that is x is equal to 1. When we ask about whether or not this is a maximum or a minimum, we can tell because it opens down that it's going to have a maximum value. So we say it's a maximum of 9 when x is equal to 1. We know that the y-intercept is an 8. Now, in terms of the graph, it's a little bit easier to understand it once you see the graph, but the domain would be x such that x is an element of the real numbers, or you can write it in the interval notation with negative infinity, comma, infinity. Range is all, if you think about the fact that it opens down, it never gets any higher than 9. So y such that y is less than or equal to 9, and y is an element of the reals. This is what we call a set notation. And the interval notation stretches so that you come from negative, all the way from negative infinity, and you go all the way up to 9. This should be a square bracket for 9. I'm just seeing that error right now, so please correct that. The x-intercepts, well, that's a little tougher because we actually wouldn't see it unless we had the graph. And the original question did have the graph. I just wanted you to try it without the graph being present. So let's look at it. This was the graph that you were given, and you can see that your intercepts are -2 and 4, and you'll notice that I wrote them here. Okay, so in other words, you can be asked to name all of these parts given this equation and given a graph as well. And that, of course, is much easier. Okay, the next question we're going to be taking a look at a real life example, which involves a frog jumping. So let's take a look at what we have. A frog is sitting on a branch and he jumps into a pond. The height, h of t, in centimeters, so this stands for centimeters, is, and this is of the frog above the surface of the water as a function of time, and t is time, in seconds since it's jumped. So if you think about what this would look like, now you're going to have to graph it to get a feeling for what it looks like, but you can tell that it's opening down. Now, if you think about it, the y-intercept is 25. And remember that h stands for centimeters, I believe. Let's look, yeah, centimeters. So the y-intercept would be 25 centimeters. And what does that represent? That represents where the frog was sitting on the twig before he jumped. Next one, what's the maximum height the frog reaches? So we're going to be looking now for the vertex. What is the maximum height and when does it reach that height? So we're going to need to use our equation, and you'll see that I actually used a calculator so that I could find it. And so I found these were my numbers when I calculated the vertex for it. So at 0.15 seconds, the frog reaches a maximum value of 36 and a half, about that. Next one, when does the frog hit the surface of the water? So if our quadratic is going like this, then when he bounces into the x-axis, we know that he's hit the surface of the water. And so we want to find the x-intercept. So we use our calculator, find that our x-intercept is 0.4. So about 0.4 seconds, he hits the water. Now the next question is going to ask you, what is the domain and the range of this function? So if you think about it, and in some ways it's kind of hard to see it without the graph in front of you, but in terms of the domain, it would stretch from 0, the beginning of time, because it would never go into negative time, to 0.4 when he hit the water. The range, just let me go back there for a second, starts at 0, and the highest he ever goes is 36.5. Okay, how high is the frog? 0.25 seconds after it jumps. So that would mean we would need to put this number in to our time spot and actually calculate it out. And you will find that it's 31.88 when you actually solve it. So at 0.25 seconds, the frog is about 31.9 centimeters high. Okay, lastly, we're going to take a look at a question that is a very typical real life problem. And this one involves a rancher that's building an enclosure, a corral. A rancher has 100 meters of fencing available to build a rectangular corral. Write a quadratic function in standard form to represent the area of the corral. Okay, well, if we're thinking the area is length times width. Now, this one doesn't help us very much because it's got two different variables. So we happen to know a little bit about the perimeter. Because it's shaped like a rectangle, we know we have 2 lengths and 2 widths. And we also know our perimeter is 100. So I'm going to rearrange things to figure out what L stands for. So I move the 2W over to this side. And I also divided everybody by 2, I guess, before I did that. So L is equal to 50 minus W. And that's just another way of referring to L. So I'm going to take that and I'm going to plop it in here and I'm going to write it. You can see I've done that here. And when I go ahead and multiply that out, what I have is a quadratic function. And so I've got 50w and negative w squared. Now, this is, if you think about this quadratic, he's a quadratic that opens down. So he's going to have a vertex, which is a maximum. Now, remember, this quadratic stands for, these values stand for the area when we have different widths. So if our width is one thing, then we'll have a smaller area. And we gradually creep up, and then we're going back down again. So the question says, what are the coordinates of the vertex, and what does this represent? So let's use our formula. Plug in our numbers and we find this is our vertex. And what this tells us, if you think about the way you actually interpret this graph has a maximum of 625 when x is 25. Now let's put a little bit more meat on that and realize that this number that's a maximum is the area. So we would say the area is a maximum of 625 meters squared when the width, it should be, is 25 meters. Sketch the graph and determine the domain and range. That's a pretty simple graph looking something like this. My domain would stretch from 0 to 0 and 0 to 50, and my range from 0 to 625. If you were going to write this in interval notation like this, because it's actually equal to these values, I would use square brackets on the either ends of these ones, just to be a little bit more exact with this one. Okay, everybody, there are some sample questions. Now, it's really crucial that you do your homework to practice and sort of refine your skills on this and make sure when you compare your answers to the solutions, if something doesn't fit, that you sort out the answer for that. And if you need help, just come and ask.